Hello everyone. This is the presentation number 2 from today's Azure night. Thank you, Milos, for the nice presentation on Bicep. It was great. So now I would like to begin with a question to the audience. How many of you are familiar with containers or Kubernetes? Okay, so pretty much everyone. Nice. So today's presentation title is Serverless Kubernetes using Azure Container Apps. It is a Kubernetes story about having options. Who am I? I am Tiberiu Arva, currently working at ABN AMRO as a cloud solutions architect and focused on Azure Cloud Platform. I would like to begin by bringing in front of you a few statistics about Kubernetes that were published by Datadog company in a report online. After analyzing more than 1.5 billion containers running by tens of thousands of customers, of Datadog customers. That report contains multiple statistics, but I have extracted these two as they relate to the subject from today. And let's look at them actually. The first one is about the managed Kubernetes service adoption. It says that nearly 90% of Kubernetes users leverage cloud managed services. This refers to the cloud managed version of Kubernetes clusters that the major cloud providers are offering, like AKS, and this has seen a significant growth as opposed to the self-managed clusters. Another interesting statistic is about the pod count per organization, and it says that the average number of pods per organization has doubled in less than 2 years. So organizations are clearly scaling on their Kubernetes environment. And while searching for statistics and facts about Kubernetes, I found also this website called Kubernetes Failure Stories, which is a compiled list of links to public failure Kubernetes stories, where people are sharing stories about their failures while managing Kubernetes cluster. And there are also big company names that have shared these kind of stories. So it's a very good read. You can find the link highlighted in yellow. So I think it's a brilliant way to share learnings and help others in their journey. So looking at these statistics and the failure website, we can see that the need for managed services is growing, the footprint of Kubernetes is increasing as well, and Kubernetes cluster management is challenging and is acknowledged by many. So maybe that is where container apps can help. But let's find out more in the next slides. In the agenda for today, first we will look at what Azure Container Apps is and a few details, the main resource concepts and features and integrations, and we will end with a few conclusions on container apps and a cool demo. What is Azure Container Apps? Azure Container Apps is serverless platform for building container-based microservices. Behind the scenes, it is being powered by Kubernetes. It is not a replacement to Kubernetes clusters, but brings the Kubernetes clusters to the serverless world. What type of apps can be hosted in Azure Container Apps? The short answer to this question would be any apps that run in a container. But looking at a few typical example scenarios, we can identify public or private API endpoints with the option to split HTTP traffic, any background processing application that you can think of, event-driven processing applications that can be easily integrated with any Azure service and not only, and deploying microservices architecture with the option to use dapr. Another important aspect about the apps from container apps is that they are easily scalable based on a variety of scale triggers, including KIDA. Now, in order to get a better understanding on Azure Container Apps, there are a few new resource concepts that it brings, and it's good to know about them before starting using it. In this picture, we can see a very good overview of the main resource concepts. We have environment, container app, revision. Environments contain container apps contain revisions, revisions contain replicas, and replicas contain the actual containers that you want to deploy to container apps. But let's find out more in the next slides by looking into them individually. Environment. Does this term sound familiar from the Azure world? Do you know any other resource that use the term environment in Azure?
App service environment.
Exactly. So this is very similar to that one. So this concept is new to the Kubernetes world, but it's not really new for Azure environment. So similar to how app service works, in an app service environment, you deploy app services. The same here, in a container app environment, you deploy container apps. Environments support integration with custom virtual network. One environment can contain one or multiple container apps, and container apps part of the same environment are sharing the same virtual network and log analytics workspace.
I have a question. To have this
Yes.
environment, is it required to have like standard or premium SKU, or you get it in every SKU?
There are no SKUs with this environment.
Okay.
It's only one type, and you just create it.
Okay,
Yeah.
thanks.
Thank you for your question. Now, there are a couple of reasons why you would want to deploy container apps in the same environment. Whenever you manage related services, it's good to place them in the same environment. When you want applications to be part of the same virtual network, this is another reason. And also, when you want the applications connect to each other using dapr. And there are also reasons why not to deploy in the same environment when you don't want the apps to share the same infrastructure. Next concept is container app. Container app manages the details of Kubernetes and container orchestration for you. Container apps can use any runtime, programming language, or development stack of your choice, using only Linux-based images published in any public or private container registry. You can have and define multiple containers in the same container app by implementing the sidecar pattern, and containers part of the same container app use the same hard disk and network resources, and also have the same lifecycle. Containers part of a container apps are grouped together in pods inside of a revision snapshot. You can have multiple revisions of a container app, and an important feature that needs to be highlighted is that it supports managed identity, and that so this allows to connect to other Azure services. And also, a very important feature that comes by default is that when a container crashes, it will restart automatically.
It is funny that Microsoft on its own service supports only Linux-based containers.
Yeah.
Are the revisions used to scale?
So could you
Are the
repeat?
revisions used to scale out?
Yes, indeed. You can use, first, revisions are actually the versions of the application, and for scaling out, you use replicas. So if you want to scale out an application, you scale the number of replicas inside of a revision. Yeah.
And you can have multiple versions of your application deployed at the same time for deployments.
Exactly.
Blue-green.
Exactly. So that is a nice bridge to the next concept, revisions, which exactly does what, that's one of the, let's say, features that it covers. So revisions inside container apps, it's actually handling the container app versioning. So a revision is an immutable snapshot of a container app version, and this can be used for easily releasing a release of updates, rolling back to a previous version, blue-green deployments, and how these revisions are created. So by default, when you create a container app, the first revision is being created, and if you do any change to any of the template properties of the container app, a new revision is being created automatically. A container app supports multiple active revisions, so at the point in time, you can actually split the traffic between active revisions of that container app.
And that is done within the app itself?
Within the app, exactly. So you can specify, there are two revision modes, single and multiple. This refers mainly to the number of active revisions. If you selected single, there will be only one, usually the latest. And if there are multiple, you can select one or multiple active revisions simultaneously. And this is a picture with an example of a container app with two active revisions. It has ingress enabled, and the traffic is being split between the two revisions, and you can actually select also percentage of the traffic that you assign to that specific revision. So in case of an update, to test the that new version, you can assign a small part of the traffic and then see how it reacts and move forward with the update. Application lifecycle management. Application lifecycle management also revolves around revisions, and it's happening in 3 stages. As we learned, it's the deployment phase, in which when we create the container app, the first revision is being created. The second stage is the update. So as the container app is updated, a new revision is being created. And the third stage is the deactivation. So once a revision is no longer needed, it can be deactivated. You can do this manually, or you can do this automatically by using the single revision mode, and this automatically takes the latest revision and makes it active and deactivates the previous one. Now, let's look at the features and integrations. We will take a look at the main and the most important ones. dapr integration. What is dapr? dapr, or Distributed Application Runtime, is a portable, event-driven runtime that simplifies the development of microservice-based applications that run in the cloud or at the edge. dapr provides best practices for common capabilities. It does this by providing distributed system building blocks when building microservice applications that developers can use in a standard way and deploy on any platform. One moment. Sorry, I was a bit thirsty. Azure Container Apps has a native integration with dapr, and you can easily enable it through a simple setting at the container app level. And once it is enabled, it exposes its HTTP and gRPC APIs via a sidecar container alongside your container. A few of the system building blocks that offered by dapr and are supported in container apps can be seen in the first picture. As building blocks like service-to-service invocation, state management, publish and subscribe, and a few more are available out of the box in Azure Container Apps. You can also create dapr components at environment level and then make them available in all or one container app part of the same environment. As you can see in the second picture, that is a typical implementation of dapr with container apps. So you have a container app environment with 2 container apps. With those settings, you simply enable dapr for a container app, and then the dapr-d sidecar container is being created automatically for you. And you can also include components which are at environment level, and these components essentially can connect two resources. In this case, in this example, it connects to Azure Service Bus, and then it's being scoped to both container apps. So both container apps can use that component and connect to the service bus.
Can you use dapr consider service mesh or no?
Yeah, it can be considered a service mesh, yeah. Moving on to the next feature, auto-scaling. So Container Apps manages automatic horizontal scaling through a set of declarative scaling rules. There are a few scaling rules available, like HTTP, TCP traffic, CPU memory, and event-driven. Container Apps also implements the KIDA scale object and HTTP scaler. What is KIDA? KIDA, or Kubernetes event-driven autoscaler. With KIDA, you can drive the scale of containers inside Kubernetes cluster based on the number of events that the application needs to process. Container Apps supports a wide variety of event types, and any event supported by KIDA is also supported in Container Apps. You can scale down your container app to 0 instances, and whenever you scale down to 0 instances, no service charges are being incurred, and yeah, we like free resources. Also, by adding or updating any scaling rule for a container app, this is being considered a revision scope change, and whenever this kind of change is done, this essentially creates a new revision of that application. And another last thing to be mentioned is that Container Apps doesn't support vertical scaling, only horizontal for now. Networking. Container Apps is being scoped to a container app environment. Container app environments are being integrated with virtual networks. And whenever you create a container app environment, you either can select to use a custom virtual network that you own, or if you don't select this option, a Microsoft managed virtual network will be created, and it will be hosted in Microsoft tenant, and you don't have access to it. Yeah, this option cannot be changed once you have created it in a way or another.
But this VNet you can create a peering with another VNet, or just like
no, so it's the resources. If you choose the Microsoft managed way, the resources are in Microsoft tenant and are hidden away from you.
It's like
and
private VNet.
Exactly, yeah. You just let's say outsource the VNet management to Microsoft, but it's good to know that you still have your environment in a virtual network. So you can consider that your container apps are like being hosted in a virtual network, and then you can benefit from the features to communicate with each other and so on. But if you want to take full control, use your custom virtual network and from the beginning, and then you will have the full experience of having a virtual network and then benefit from all the features.
Just one thing to add regarding networking that my team discovered is that the custom VNet has a specific limitation. The minimum subnet size at the moment is /23, just like when you deploy the AKS. So if you're planning to use this solution for a small number of apps, yeah, I'm not sure if it's worth it with the /23. So keep that in mind. Yeah, it's VNet integrated, great, but it takes a lot of IPs for it.
Yep. Thank you for addition, Milos. And then to continue, it uses the Envoy proxy as an edge HTTP proxy, and you can define traffic rules between active revisions of the application. Ingress is another component that comes out of the box with Azure Container Apps. You can set a container app with an external or internal accessible ingress. Internal means that you expose that ingress only in the virtual network, and external, you expose it publicly. And whenever you enable an ingress for a container app, it also gets an FQDN and automatically. And it's good to know that internal and external FQDNs are a bit different. Yeah, it's good information. Let's go to the next slide, monitoring. After you have deployed your container app, continuous monitoring is very important to identify issues in case they may appear. Container Apps has a rich integration with monitoring features like log streaming for viewing console streaming logs in near real time of the container, for having access to a container console, so you can directly get into the console of the container and run debugging commands, for example. And also integration with Azure Monitor, log analytics for viewing the application logs, metrics for viewing key metrics of your application and container apps, and alerts for configuring alerts based on your requirements. There is also an important monitoring Azure resource, Azure Application Insights, which is not built in with Azure Container Apps, but you can include it in the web framework of your application inside the container, and that we're using Azure Application Insights SDK, but it doesn't have, let's say, a native integration with Container Apps yet. Authentication part, Container Apps provides a built-in authentication and authorization feature that secures your external ingress-enabled container apps with minimal to no code. The built-in authentication feature uses, so the built-in authentication feature can save you time and effort by providing an out-of-the-box authentication feature using federated identity providers that lets you focus more on the application and not on the authentication part. As we can see in the picture, the authentication module runs in a sidecar container isolated from your application container, and the inbound HTTP traffic first reaches the authentication module, and then it is being handled by your container, by your application container. Of course, it's not required to use it. It is an extra feature that you can use, and of course, you can use as well the authentication feature of the web framework of the app that you place in Container Apps or any other authentication feature.
Oh, question.
Sure.
Is it under the hood using B2C, Azure B2C, or just federation, plain federation?
I'm not aware of this. This would work. I personally don't think it uses B2C. I think it's using, let's say, a container-based solution which is running as a sidecar, and it offers out of this box these type of integrations. These are the available providers that you can easily integrate. Yeah. So it uses federated identity. Yeah.
Okay. All those sidecar containers that you mentioned, they do take part of your resources from the app.
Yes, yes. So your container app actually is this one. So your container app contains your application container, and when you enable this feature, another container will be running alongside your container. The same as with dapr, if you enable dapr, another container is in the same container app. Yeah.
But you need to, does it let's say auto-size for this additional resource on the pod, or just like anytime you happen to define the pod capability?
Yeah. So actually, the revision is actually, let's say, a pod. Containers in the container apps are actually grouped together in pods. And these revisions are just some snapshots of that pod configuration at that moment in time. So actually that revision is essentially a new configuration of the pod. Yeah. Okay, let's go to the next one. Quotas. Before starting using container apps, it's good to know that there are a couple of quotas that are being enforced. So on a subscription level, you can have maximum 5 environments, maximum 20 container apps per environment, and a few more. And another limitation that I just discovered in my case, that for pay-as-you-go subscriptions, you can deploy only maximum 1 environment. So yeah, this is for the other types of subscriptions. Now, patching. And of course, there is no patching. It's Azure Container Apps is serverless. Conclusions. So, what are the key takeaways of this presentation? So first, we looked at what Azure Container Apps is. It's a serverless platform for building container-based microservices. Then we looked at the main resource concepts and how they relate to each other: environment, container app, and revision. And we also took a deeper look into the main and most important features and integration, like dapr, auto-scaling using KIDA as well, networking, the integration with the custom virtual network or Microsoft managed virtual network, the monitoring part using various tools, and the authentication using the built-in features. When to use Azure Container Apps? So Azure Container Apps takes a more app-centric approach that lets you focus more on the application than on the cluster management. So if you are at the beginning with Kubernetes, but you like containers and you want to use them, Azure Container Apps could be a very good choice. If you are looking for this serverless experience and native integrations with dapr, KIDA, then Container Apps could be a very good choice. And this is suited also for applications that have simpler orchestration needs. And of course, when not to use Azure Container Apps, if you need access to Kubernetes API, then Container Apps is not a good choice. This is not available. If you want to use your own service mesh or any other option, again, Container Apps might not be a good choice. You have limited options available, like the ones we just discussed. And if your application runs in Windows containers, this is not supported. Now, the demo part. How the demo will be structured? There will be 2 demos. In both demos, we will deploy 2 applications that interact with each other. In the first demo, we will use Azure CLI to deploy it, and we'll take a look on how that is done. And also, we will demonstrate auto-scaling for one of the container apps from that solution. And the demo number 2, we will deploy again 2 applications using bicep templates. So we can leverage the knowledge that we just got from Mila's presentation. And those applications have dapr integration, and we can take a look and how that is enabled and how that works. Demo number 1. Here, a more detailed look, what we will learn. So we will look at the Azure subscription prerequisites for running Azure Container Apps. And then we will deploy the applications that are in the diagram. So we will deploy one environment with 2 container apps, a front end and a back end. The front end displays a nice UI with information received from the back end. Back end is exposing one API for receiving some information. It's about albums information. And the front-end API has an external ingress enabled, and I also enabled it for the backend as well for testing purposes to see that it works and everything is all right. We will demonstrate the communication between 2 services. We'll enable then auto-scaling for container app number 2. So the backend, we will manually enable auto-scaling, look how that is done, and then we will actually test it. We will trigger some requests to see live how easy the scaling is done. So let's go to the Okay, it's becoming clearer.
Is it me or is it German?
Okay.
Yeah, just had one beer then. Yeah, better.
Yeah,
That's good, we can see.
Yeah.
you can see? Perfect. Okay.
Select all.
Yeah, I think it's a focus setting probably.
Yeah.
Yeah. So I created this repo. You can find it also in the slides. So first, it has in the structure it's demo1 files, demo2, and a couple of samples. And here are the prerequisites for an Azure subscription. First, you need to add the Azure CLI Container App extension. Then
With blurry, yeah.
Select everything.
Yeah.
I'll leave it selected.
And
Yeah.
if you stop scrolling, then it gradually unblurs.
Yeah, so I think if it's all selected, I will just hover with the mouse to see where I'm referring to,
Okay.
because otherwise there will be a mismatch. So first is the adding the Container App extension for the Azure CLI to have all the Container App Azure CLI commands available on your computer or in the terminal that you're running the commands, and then at a subscription level to enable two resource providers, actually one for Container App, Microsoft.app for Container Apps, and Operational Insights for Log Analytics Workspace if you don't have it already enabled. Then let's get into demo 1. So this is the deployment file. This is the deployment file. It's actually this is the demo in which we will deploy the application using Azure CLI. So what happens here? We declare a couple of variables. We create the prerequisite resources. Of course, the resource group. Then an Azure Container Registry for hosting the images of the containers. In this demo, we will build the images ourselves and we will publish them in the Container App. In the second demo, we will use images that are already published publicly in Docker Hub. Then we will create a Log Analytics workspace and retrieve the workspace ID and workspace key. There is the option also to not create one for yourself, and while you create the Container App environment, then a workspace will be created for you, but it will have a custom name with some random numbers. And if you don't want that, you can create it yourself before. And then these are the commands for deploying your Container App environment. You specify a name, resource group. You reference the Log Analytics workspace ID and key for using it for logging, and the location. Yeah. So once the environment is deployed, then we will go to the application deployment phase. First, as mentioned at the beginning, we will build the images ourselves. So all the apps from these two demos are Microsoft samples used in their documentation. So I'm reusing what they provide. I have forked the code to my repository, and what I'm doing here, I'm cloning it, and then I'm using ACR build, which is building the applications locally and then pushes them to container registry, and then we will have a published image in the container registry. And then it's the Container App create, which actually creates the Container App. As properties, you need to introduce a name of the Container App, a resource group, reference the environment in which you want to deploy the Container App, specify the image path together with the container registry FQDN. Then the target port of the container, we set the ingress to external. This is the backend API. This would have been also internal, as the applications would have communicated inside the virtual network. We also specify the container registry server, and using the query parameter, this displays only the FQDN when the command finishes. The same is done also for the front-end UI, cloning the repo, building the image, and another step that is different from the backend. We are also saving the API base URL of the, this is the FQDN of the ingress that was enabled for the container app backend. This is needed because when we are creating the container app, the front-end container app, we are using the API base URL as environment variable so that the front-end knows which backend it connects to. And it has the same settings, same with ingress enabled, external, and just referencing the other image and providing another name. Now, for, let's say, timing purposes, I already deployed these resources. And on the demo number 2, we will deploy it together. The reason for that is that container app environment takes some time to be deployed, and then when we run demo 2, we will use the same environment because deleting it takes around 10-15 minutes, at least sometimes, but it takes a long time, so it's not predictable. So if we look at the resources that we just reviewed with the Azure CLI, so it's Log Analytics Workspace, which essentially stores the logs of the application. Then the container registry, Log Analytics for storing the application logs, container registry for storing the images. So the API and the UI. These are from today. Then we have the container apps, but let's look first at the container app environment, how it looks like. So in the container app environment is having quite a simple interface.
Maybe,
Here.
Maybe a zoom.
Yep. Better? Better? Okay, so here at the environment level, we just look at the dapr components. This is from the second demo, is not currently being used. So here you can find the components and the applications. And in the logging options, you can view the log analytics integration with the one that we just created. Now, let's look at the applications. So as we learned in the presentation, there are many features, but we will focus on the main ones. So we have here revision management. Here it will be displayed the revisions. And from here, you change the revision mode, single or multiple. Here you can see container details, the name, container registry, OS type, and these kind of informations, and also the environment variables. Scaling, here we are defining the scaling rules, and for this we will also implement the scaling rule. So let's do it together now. We click edit, we go to scale, you set a minimum and maximum replica number. So let's go wild and go with 20. This is just a minimum and a max, but the scaling will be done based on load. And yeah, test, we will use HTTP scaler, test HTTP scaling, and for triggering multiple replicas in short amount of time, I will just put, for testing purposes, one concurrent request. So based on this threshold, Container Apps decides how many Container Apps replicas are being created. So it's that easy to set a rule. We create it, and it will be saved in a couple of seconds. Until it's saved, we can look at the log stream. So this is actually, you can view the console streaming logs in near real time. And here you can see the replicas of that revision and the containers inside that revision. And with the console feature, you can use bash and run commands directly in the container, directly from Azure portal, which is really helpful for whenever you're developing the application and debugging it. And in the logs, you have here container app console logs. And here are being saved, actually the logs that are being outputted by the application are being saved in log analytics. There are two tables, console app console logs, container app console logs, and then system logs of the container app. Now, okay, if we look at the UI, it's the same thing. So we have one revision with container scale, so it's just a different container with the UI. And if we look at what the application does, we can go to overview on the application URL and access the FQDN of the ingress of the application. And we can see the application that is running in container apps. It's actually a list of hits, and the latest hit is the Azure Knight with Tiberiu and Milos. So from where does it get this information? It gets it from the Album API. So if we go on the API and look at albums, this is actually the information that is being displayed in the front end through this API, and they communicate. The front end calls the back end. Okay, so now let's test the auto scaling. So as we did earlier, we enabled scaling with an HTTP scaler with concurrent request of 1. So now I will use PowerShell to generate some dummy requests. I will replace the URL as a container app, and okay, I'm generating some requests to that application to watch how the scaling works. Okay, you see already 2 replicas have been created. Okay, let's okay, we can see right now it's at 4. So it's actually really fast in scaling the environment horizontally and scaling it out and scaling it in automatically based on the number of requests. And you can see right now there are not so many requests, and it's already scaling in, now scaling out. I think it has some delay, but here you can navigate to other replica, and then you view the logs from there. So that's how the HTTP scaler works. Yeah, this issue occurs sometime if we refresh it multiple times or we send too many requests. This is what I have noticed as well. But it's coming back in a few minutes. Okay, so this was demo 1. Now let's remove the resources except the container app environment. I noticed that the deletion is done really quick. And we can move to the next demo. So the next demo is the same. We will deploy 2 applications, other 2 applications. Also, these are Microsoft samples. So there is a container app client Python application and the container app service Node.js application. What is different from demo 1 is that they have dapr enabled and they communicate with each other through dapr. So here there are 2 system building blocks of dapr demoed. So it's the service-to-service communication between Python and Node.js, Python calling the Node.js app, and the communication between the Node.js and Azure storage. It's a state management building block. So it is being created a component that connects to the Azure storage. So how this would work, there is the client application calling an API on the service application, and then that service application is saving that payload to the Azure storage. So we will take a look at that. This application is being deployed using Bicep, So it will be a good way to put in practice what we learned earlier. And it will be demonstrated the communication between the two services, the dapr component for Azure storage, and the bicep deployment. So right now, the resources from demo 1 have been cleaned up. Demo 2. So here we have the code of the applications. Here is the bicep template, and this is the deployment file. I will do the deployment from the beginning, as it takes some time to deploy the resources. So let's be proactive and do that. So what this deployment file does, takes a couple of parameters, and we are just creating a storage account for storing the state. Sorry, I think it's blurry. We are just creating a storage account for storing the state using dapr, and we will deploy the bicep template through a resource group deployment. So it's nothing special here. I'll just deploy this. Logging in. Okay, so while it's deploying, let's take a look at the bicep template. Yeah, it's a nice feature. While it's highlighted, it can be seen. So this is, let's say, a bit more basic than the concepts explained by Milos. So we just define a couple of parameters, a few variables, and we are deploying the resources. So again, we are creating a log analytics workspace with default configuration. What is new here is that we also create an application insights resource. This is used for streaming the dapr logs. So the dapr sidecar containers have an integration with this app insights resource, and then we create an environment. In the environment, we also use the default configuration with the name and the location. And here we specify the dapr AI instrumentation key, application insights instrumentation key, and also we reference the log analytics that we just created. Then inside of the environment component, we are also creating the dapr component, as this is created at environment level, and we are just give it a name and specify is of type blob storage, few default settings, and we are storing the storage account key, account name, container name, and account key as metadata and secret. And we scope it only to the node app. This node app is actually the application ID. Whenever, well, but now it's selected and it's not visible.
Yes.
Come on. I'm good at explaining, but not that good to explain the code line by line. Huh? Let me close the file and open it again.
What is the beamer, right?
It's trying to focus.
Maybe because of all the black on the screen. Yeah.
Maybe switch to white.
Yeah, something.
Switch to a non-dark theme.
Yeah,
It wasn't as bad with the presentation.
It's good.
Yeah. So now we can see some part. Let me try some more. Okay. Yeah. So here is the part where the dapr component is deployed, and then we are deploying the actual container apps. We provide a name, a location, then to which environment we are deploying the container app. This is the setting for enabling the ingress. You just specify if it's external and you give the target port of the container. And then for enabling dapr, this is all you need to add. You just specify it's enabled. And then this app ID is actually the one referenced by the component as being scoped. and again the app protocol and app port. And inside template containers, this is an array that contains all the container, let's say, definitions that you want to deploy in that container app. You can have one or more. So here we are using a publicly available sample from Docker Hub. We give it a name, we set an environment variable, and we specify the resources that we want to assign to this container app. And default scaling to 1. Same for the Python app, name, location, the same environment ID. We enable dapr, and in the template we introduce the image definition with the image name, the name of the container, and the resources, and the default scaling configuration. So I think this just finished deploying, and if we look here, the resources have just been created. What is new on the container app level is that we have the dapr component. It's called the state store, the Azure storage, and containing the secrets and metadata which is used by the application to connect to the store. Okay. In the application insights, so here we can see only dapr logs. Let's hope that the logs already, it's not yet available, but should come quite quickly. Then we have the storage account. So this is the store of the data on which the service application will write data with dapr. And inside containers, there is my container, and here is the data that it writes. We will take a look soon. And the Node app and the Python app. And what is different to these apps? Let's go to Node app to demonstrate how the dapr is configured. Here in the replica, we have one replica, but here we have two containers. So alongside the container declaration, as you see in the template, we actually define only this container, and just by enabling dapr, we have a new container running alongside of it. And here we see the console logs of the application. So what this app does, it exposes two APIs, one for order and new order, or /order is for seeing what is, let's say, the order ID provided by the client Python app, and the new order is actually writing the new order payload to the store. So if we look here, got the new order. So these are requests received from the client, from the Python app, and this is outputting in the console, and it's also writing in the store. So we can see here 298 order, and here 300. So this is constantly updated, and I was telling you about that API, that you can view what is in the store. So with this API, essentially the Node.js app also looks up in the storage account what is that data. So if we look in the order, we also see the current order ID, and this just is being retrieved constantly as this is changed. Okay, and the same for the Python app. It's also having the dapr component, and they communicate through the dapr. Both the client and the service are communicating through dapr. So the service-to-service communication, and then the service app is communicating to the state store using dapr. And that concludes also the second demo. And we arrive to the Q&A session. Are there any questions?
Is it fair to say that it is a control plane as a service? Like it's abstracting the kube control kind of thing? You just need
Yeah.
user
So
namespace?
So it's powered by Kubernetes. Behind, it's running actually, I'm not sure exactly how it's running, but probably it's part of a bigger cluster or it creates something specific. But it's an abstraction on the Kubernetes cluster. You can see many of the terms and concepts from the Kubernetes here. And it tries to bring to take away all the let's say complexity of having to enable an ingress. That's some work to do. Having to enable dapr, having to scale it, to implement KIDA. So this they try to make it really simple so that you really focus on the application and use these features to easily go to production. So you have no infrastructure to maintain. You just deploy a container. You have all these cool features with splitting traffic and everything. I think it's really helpful. But if you fit to these scenarios that are currently supported, then this could be a really good option. Or you can make your application fit these scenarios and leverage it. Or who knows, maybe this will be, let's say, further developed and multiple features will be added if this will be and already is a success.
Yeah, it's a relatively young service, so with the requirements from the Microsoft stakeholders, there will probably be new features in the upcoming years.
Yeah, and that statistic from the beginning was really, I was really also impressed that many customers, many users are moving to this managed version of Kubernetes, probably that being the first step in favor of the self-managed cluster. And then probably who knows what the next step is, if that version is enough these, let's say, more managed versions could be used. But it's a good step forward.
How easy it is to connect the services without using dapr?
So it's really easy because when you have a service, so you have an application, you deploy it in a container app. That container app it's in an environment, and the environment is in a virtual network. Whenever it's in a virtual network, that container will get an IP. So essentially, if you deploy another container app in the same environment, they will be in the same virtual network, and you can just call it on the APIs or whatever it exposes directly, either by the name of the container app or as you do in Kubernetes, or by the IP of it. Yeah.
Okay. So
Yes.
you don't have to necessarily use dapr.
No. dapr is just an option that you can enable it easily, but you can use it very well without it.
Yeah.
Yep.
Yeah. And how is the cost of using container apps compared to AKS?
From what I saw, container apps have a cost model similar to function apps. They have this serverless model based on number of requests and the number of CPU you assign. There are also, I think we can look it up really quick. There are also some free number of requests that you receive by default per month. And then, depending on your situation, then let's see. Yeah. So for number of requests, you have $0.40 per million, and you have a free grant of 2 million per month. And also the virtual CPU per second is, this amount. And you also have this free grant per month. That is,
So that
considerable.
might be a lot less costly than, say, an app service.
Yeah, so
If you
it's a
don't use
different
both.
model. On app service, you pay for the tier. So depending on the tier you choose, you pay a certain amount fixed per month. But here, it's based on the traffic that you will have on the container apps. Yeah. So you don't have...
less than web app for containers, for example.
Yeah. Because if you scale it to 0, there are no service charges incurred. You can still have the resources there, but if you scale it to 0, then it will cost you nothing. So that's why event-driven could be a good use cases for this. Yeah. If there are no other questions, I think we can conclude this second session from tonight. I want to thank you all for being a great public, and I hope this was informative. For me, it was, for sure.
Thank you.
Yeah,
Great.
thank you. Yeah.
Get something to say?
Yeah, well, I wanted to thank everyone that who attended. We are looking for speakers. If you want to come and show us what you know, well, more than welcome. One unfortunate news, we haven't received PISA due to